Hello everyone, welcome to third sem. Hope you all are safe with your family. Now, in this third sem, I am going to handle physical pharmaceutics subject. Today, we will see the introduction of physical pharmaceutics. In that, we will see physical pharmaceutics definition, objective, what are the different units are there in your syllabus, then some introductory part of first unit. Okay, now what is physical pharmaceutics? Physical pharmaceutics, it is the branch of pharmacy that concentrate on the application of physics and chemistry to the study of pharmaceutics. Okay, you know that pharmaceutics means study of dosage form. So application of physics and chemistry to study of the different dosage forms is known as physical pharmaceutics. In other words, we can say study of effects of dosage form at molecular level. जो भी डोसेज फॉर्म है उनकी स्टडी एट मोलिकुलर level is called as physical pharmaceutics. Now, while we are saying that application of physics and chemistry to study of pharmaceutics, what are the different physiochemical parameters we have to see here are like solubility, diffusion, dissolution, then chemical kinetics, complexation, absorption, adsorption, then state of matter, surface interfacial tension, all these physiochemical parameters we have to see under the physical pharmaceutics, how they affect or what are their effects on the dosage forms at the molecular level. Okay, now what what is the objective of physical pharmaceutics? Why we have to study? To understand various physiochemical properties of drug molecule in the designing of dosage forms and formulation development. जब भी हम dosage form develop करते हैं in formulation development department, first we have to see that physiochemical properties of drug molecule, whether that drug molecule is suitable for that dosage form or not. Now, for understanding that physiochemical properties, we have to study the physical pharmaceutics. Okay. Next, know the principle of chemical kinetics and use them for stability testing. Now, what is chemical kinetics? Chemical kinetics means chemical reactions involved in the uh, drug degradation process. Okay. Stability testing is nothing but whether a drug is stable during a particular period of time, or it undergoes any degradative pathways that will help to determination of expiry date of formulation. अभी expiry date कैसे ये करते हैं, डिटरमाइन करते हैं स्टेबिलिटी टेस्टिंग के ऊपर. और स्टेबिलिटी टेस्टिंग कैसे करते हैं, जो भी केमिकल काइनेटिक्स रहते हैं ड्रग मोलिक्यूल के, केमिकल रिएक्शंस which drug molecule undergoes degradation, that all these things we have to study. Now I think chemical kinetics, it is not there in third sem, it will comes in fourth sem pp2 part. Okay, so coming to your syllabus part, there are 5 units in your syllabus. First unit is solubility of drugs. In that solubility of drugs, we have to see first some definitions, then solubility expression, then according to different pharmacopoeia, then mechanism of solute and solvent, how solute is interact with solvent to form a soluble solution. Next, ideal solubility parameters, solvation, what is solvation, association, then quantity. approach for factors affecting influencing solubility of drugs. Okay, in that factors, solute, solvent, environmental factors, formulation factors will come. Then diffusion principle we have to see. Diffusion principles, I think you have studied in first sem also. Here in detail again we have to see. Then some theories of solutions are there, in that solubility of gas in liquids, solubility of liquids in liquids we have to see. Raoult's law, it is Raoult's law comes under theories of solutions, ideal solution, binary solution, real solutions. All these things are very important for your exam point of view also. Okay, then partially miscible liquids, critical solution temperature and application, distribution law, its limitation and application. Now coming to second unit, it is a states of matter and properties of matter. In that first point is state of matter. You know that matter, uh, it will be either solid, liquid, gas. Means in physical phase, in chemical it will be either pure state or complex or chemical substance. Then changes in the state of matter, in that we have to see the physical changes, chemical changes, then some uh, definitions and explanation about the latent heats, vapor pressure, sublimation, critical point, eutectic mixtures. Now in gases we have to see different gas laws like Boyle's law, Charles law, Gay-Lussac, Gay-Lussac law. Then one more important ideal gas equation we have to see: aerosols, inhalers, then relative humidity, liquid complexes. In liquid complexes again, types of in liquid crystals, types of liquid crystals, glassy state, types of glassy state. In solids again we have to see what is crystalline substance, amorphous substance, then subtypes of crystalline and amorphous substance, their explanation. Then polymorphism, what is polymer morph, their different types we have to see. Okay, all these things we have to see in first part of unit 2, that is state of matters and properties of matter. In second part of second unit we have to see physiochemical properties of drug molecule. Some of the physiochemical properties like refractive index, optical rotation, then dielectric constant, dipole moment, dissociation constant. uh, all these things we have to see under physiochemical properties. Now these physiochemical properties provides information regarding interaction between the molecular structure and the drug action. How this will how these properties reflects on the drug actions we have to see here. In this part we have to see definition of all these things, then theory behind all these parameters, instrument used for identify refractive index, optical rotation, dielectric constant, dipole moment, dissociation constant, and their applications. Okay, in exam they might be asked what is the refractive index, which instrument use, means otherwise particular instrument they will ask, and their applications. Similarly, optical rotation, dipole moment, all this is okay. Now coming to third unit third is surface and interfacial phenomena. Here we have to see liquid interface. Now surface and interfacial phenomena. Surface phenomena means there will be a interaction between gas and liquid, and interfacial usually there will be an interaction between two immiscible liquid. where interface will occur. We will see in detail there. Again, here we have to see liquid, what is liquid interface, what is surface and interfacial tension, what is surface free energy, measurement of surface and interfacial tension. Now here some methods are there, like capillary rise method, drop weight method, Dunoy ring method. Yes, all these things. Many times they will ask either capillary rise method or Dunoy ring method, or write a note on measurement of surface and interfacial tension for long answers also. Okay. Next, what is spreading coefficient? Then adsorption at liquid interface. There are two theories in that: negative adsorption and positive adsorption. Then surface active agent. This is also called as surfactants. Surfactants means those having both groups, the compound or molecule having both groups, hydrophilic as well as hydrophobic group. Now, based on that hydrophobic and hydrophilic group or lipophilic group, that surfactants are divided into different categories, and that determination depends upon the HLB scale. Now, HLB scale, it will be from 0 to 20, like pH from 0 to 14. HLB scale will be like 0 to 20. Those having hydrophilic nature will be below 10. Those having lipophilic nature will be below 10. Those having hydrophilic nature will be above 10. All these things we have to see here in HLB scale. Next is theory of solubilization, detergency, how detergents will act, how soluble means how different surface active agents acts for increasing solubility of insoluble drugs. All those things we have to study in solubilization. Next is detergency, then adsorption at solid interface. Here I think two theorem will comes. One is Friendlich adsorption theorem, and another one is uh, one more is there, Langmuir adsorption theorem. Okay, these things we have to see here in unit 3rd. Unit 4 is complexation and protein binding. What is the role of complexation? Complexation means drug molecule will complex with the any other substances. Now, introduction in classification. There are different class like metal complexes, organic complexes, inclusive complexes, and there are again subtypes of complexation: organic complexation, metal complexation, and inclusive complexation. This topic is very important for your exam point of view. Many questions will come from this complexation and protein binding, and very easy also to understand. Okay. Next, what are the application of complexation? What are the method of analysis? There are 5 to 6 methods are there. This will be also asked in your exams, like complexation titration method, then solubility method, then spectroscopy method. All these things will comes under method of analysis. Next is protein binding, how drugs will binds with the protein molecule in the body. There are different protein molecules in the body. So how drugs will bind with those protein molecules? What are their effects uh, in complexation and drug action? What are their effects, negative effect or positive effect? We have to see under that. Next is crystalline structure of complexes and thermodynamic treatment of stability constant. Okay, these things we have to see in unit 4. Unit 5, This one is very easy, I think, for you. If you have studied properly in inorganic chemistry, pH, buffers, and isotonic solution, some basic idea still, if you have from the inorganic chemistry, this will be a very easy, because all the points whatever we have covered in the inorganic chemistry first same points will become here. Little bit extra, some parts we have to add here. Here Sorensen's pH scale, what is Sorensen's pH scale, that we have to see. Then pH determination, I think this was not there in first sem, that we have to see here. Electrometric and calorimetric methods of pH determination. Application of buffers we have seen in first sem also. Vapor equation, that is Henderson-Hasselbalch equation, HH equation. Again, how we have to see how it will derive. Then buffer capacity also we have seen. Buffers in pharmaceuticals and biological systems. Buffered isotonic solutions. There are different buffered isotonic solutions. Also we have studied in first sem. Again we have to see here what is isotonic solution, what is hypotonic solution, what is hypertonic, paratonic solution. All those things we have to study in unit 5. And I think in all 5 units this will be easy for you if you have studied properly in first sem. Okay, now this is all about your PP syllabus. There are 5 units. Unit 1, 2, 3, 4, 5. 5 units are there in your syllabus. Now next, what books you have to refer. Now, Physical Pharmacy by Alfred Martin. This is a standard, one of the standard book for the physical pharmaceutic. Most means अभी पीवी निराली ऐसे आ रहे, लेकिन पुराने जब हम बी फार्म में थे तो हमारे सर लोग यही रेफर करते थे, मार्टिन मार्टिन नहीं तो सीवीएस सुब्रमण्यम। अभी कंसाइज साइज में आपको पीवी निराली ये सब कुछ मिलता है, लेकिन वो भी कॉपी पेस्ट रहते हैं। अल्फ्रेड मार्टिन नहीं तो सीवीएस सुब्रमण्यम का कॉपी पेस्ट करके उधर चिपकाया रहता है। ओके, सो दिस इज आई विल से, ऐसा नहीं है कि आप पीवी मत यूज़ करो, निराली मत यूज़ करो, बट एटलीस्ट वंस यू रीड दिस बुक, okay, Alfred Martin, and then CVS also is very good. Okay, next, coming to your first topic, that is unit 1. I will start with solubility of drugs. Now in solubility of drugs, uh, first we have to understand some basic terms. What is solubility, what is solvent and solute, what is saturated solution, what is unsaturated solution, what is supersaturated solution, what is molarity, what is normality, what is percentage weight by volume, percentage volume by volume, percentage weight by weight. Now you pause the video. I think all these things you studied in earlier same or somewhere you have studied all these things, because these are some basic terms. You pause the video, you try to get those terms. Okay, then we will see what is solubility. Now next, solubility. What is solubility? Solubility at a definite temperature, it is a maximum amount of solute dissolved in a amount of solution. At definite temperature, maximum amount of solute get dissolved in an amount of solution, that is called as a solubility. Simple. Now next, what is solute and solvent? Now solute, it is a dissolved substance in solution. जो भी dissolve होता है solution में उसको हम क्या बोलते हैं? Solute बोलते हैं. Then what is solvent? सॉल्वेंट इज अ कंपोनेंट विच हैव एबिलिटी टू डिजोल्व द सॉल्यूट, जो डिजोल्व करके लेता है, जो डिजोल्व होता है उसको सॉल्यूट बोलते हैं, और जो करके लेता है उसको सॉल्वेंट बोलते हैं, सिंपल। नेक्स्ट, व्हाट इज सैचुरेटेड सॉल्यूशन? व्हाट इज सैचुरेटेड solution? Now, saturated solution, it is defined as solution in which solvent in equilibrium with solid phase or solid phase। इसमें क्या रहता है, सॉल्यूट और सॉल्वेंट इक्विलिब्रियम फेज में रहते हैं। इन अनसैचुरेटेड स्टेट में क्या रहता है, व्हाट इज अनसैचुरेटेड सॉल्यूशन? जो भी सॉल्यूट कॉन्सेंट्रेशन रहता है वो कंप्लीट नहीं रहता है, but we can say those having dissolved solute in concentration below that necessary complete saturation। जो complete saturation के लिए जो solute concentration रहता है उससे कम इसमें unsaturated solution में रहता है। एंड व्हाट इज सुपर सैचुरेटेड? उसमें ओवर कॉन्सेंट्रेशन रहता है सॉल्यूट का। दोज सॉल्यूशन हैविंग ओवर concentration of solute than the saturated solution is called as super saturated। यहाँ पे इक्विलिब्रियम कॉन्सेंट्रेशन रहता है, यहाँ पे लेस कॉन्सेंट्रेशन रहता है, एंड यहाँ इन दिस सुपर सैचुरेटेड मोर कॉन्सेंट्रेशन विल बी then there। then what is molarity? Molarity, it is number of moles of solute per liter of solution, number of moles of solute per liter of solution। then what is molality? Number of moles of solute per 1000 gram of solution, solvent। Here 1 liter, here 1000 gram, that is the difference between molarity and molality। now what is moles? Again you have to go to your basics, what is moles, all these things already you have studied in organic chemistry also, I think in PUC level also you have studied all these things, molarity, molality। then what is normality? Normality, it is a number of gram equivalent weight of solute in 1 liter of solution at a given temperature। now what is gram equivalent weight? This is also you studied in PUC level, what is gram equivalent weight? Okay, there is molecular weight divided by valency, or other methods are also there to identify the gram equivalent weight of particular molecule। okay, I will not go there in that detail here। next is what is percentage weight by volume, percentage volume by volume, percentage weight by weight। all these things you have studied in first sem pharmaceutics। percentage weight by volume means it is expressed as gram of solute in 100 ml of solution। suppose 1 gram of 1 gram of solution, sorry, 1 gram of solute in 100 ml of solution, it is called as 1% weight by volume। like that 1 ml of solution in 100 ml of solvent, sorry, 1 ml of solute in 100 ml of solvent, it is called as 1% volume by volume। then 1 gram of solute in 100 gram of solvent, it is called as 1% weight by weight। okay, सॉरी फॉर द डिस्टर्बेंस, थोड़ी पूजा चल रही है यहाँ पे। ओके, नाउ इन solubility of drugs, first point is solubility expression। now how solubility will be expressed? solubility expressed in many ways, and this will be a first point in your solubility of drugs unit 1। how solubility will be, solubility of solute expressed in many ways according to BP, British Pharmacopoeia, it is expressed in ppm and milligram per ml and in moles per liter, either in ppm, milligrams per ml, moles per liter. Okay, according to USP and IP, it is described as part of solvents required for the parts of solute. Part of solute means how much parts of solvents required for the part of solute, and according to which solubility described in the 7 groups. I think this one we studied in the inorganic chemistry, while ये कहाँ पे, हाँ, जब हम फार्माकोपिया पढ़ रहे थे इन डिटेल्स अबाउट मोनोग्राफ्स में आता था वो, व्हाट आर द कंटेंट्स ऑफ मोनोग्राफ्स, उसमें सोल्यूबिलिटी, हाउ सोल्यूबिलिटी विल बी एक्सप्रेस, उसमें जो अकॉर्डिंग टू यूएसपी आईपी, one part dissolved in one part of solvent, what it called, one part of solvent solute dissolved in 10 part of solvent, what it called. According to that 7 groups we have seen: soluble, very soluble, that again we have to see here. Solubility expressions according to BP, according to USP and IP. Now quantitatively, solubility also expressed in molarity and percentage, in percent weight by volume or percent weight by weight. Now next, solubility description as per ISP and USP, we have to see this chart, we have to remember. Okay, in IP it is approximate volume of solvent in ml, मीन्स जो सॉल्वेंट रहता है वो ml में एक्सप्रेस करते हैं फॉर 1 ग्राम ऑफ सॉल्यूट। अगर हमने 1 ग्राम सॉल्यूट लिया है तो कितना सॉल्वेंट लगता है फॉर सपोज वेरी सॉल्युबल, फ्रीली सॉल्युबल, जो अभी 7 ग्रुप्स है। सपोज 1 ग्राम ऑफ सॉल्यूट लिया है and solvent is less than 1 ml, then it is called as very soluble. अगर 1 ग्राम ऑफ सॉल्यूट लिया है, अगर सॉल्वेंट 1 to 10 ml रहा तो इट इज कॉल्ड एज, अगर 1 ग्राम ऑफ सॉल्यूट है और सॉल्वेंट 10 to 30 ml है, मीन्स 20 ml में अगर 1 ग्राम सॉल्यूट हो रहा है तो उसको हम सॉल्यूबल बोलते हैं। सपोज फॉर एग्जांपल हमने शुगर लिया, 1 ग्राम ऑफ शुगर लिया, वो 1 ml में डिजोल्व हो गया, बिलो 1 ml, तो उसको बोलेंगे वेरी सॉल्यूबल। अगर वो 1 to 10 ml में डिजोल्व हो गया तो उसको बोलेंगे फ्रीली सॉल्यूबल। अगर 10 to 30 हो गया तो सॉल्यूबल। ऐसे अगर 1 ग्राम ऑफ अदर सब्सटेंस कौन सा भी लिया, वो अगर 30 to 100 ml के बीच में डिजोल्व हो रहा है, सपोज 50 ml सॉल्वेंट में डिजोल्व हो रहा है 1 ग्राम, उसको क्या बोलेंगे? स्पेरिंगली सोल्यूबल। स्लाइटली सोल्यूबल 100 to 1000 मीन्स 100 ml और 1 लीटर सोल्यूशन, उसमें वो 1 ग्राम सॉल्यूट डिजोल्व हो रहा है तो उसको स्लाइटली सोल्यूबल। वेरी स्लाइटली 1000 मीन्स 1 लीटर to 10 लीटर, 1000 ml to 10,000 लीटर, sorry 10,000 ml, 10 liter, and insoluble or practically insoluble more than 10,000 ml, that is more than 10 लीटर। सपोज 1 ग्राम हमने कौन सा भी सब्सटेंस लिया है और अगर वो 10 लीटर तक सॉल्वेंट में भी नहीं डिजोल्व हो रहा है तो उसको क्या बोल लेंगे हम? इनसॉल्युबल और प्रैक्टिकली इनसॉल्युबल, like that. Now this is about IP. In USP, what they will say, it is part of solvent for 1 part of, हाँ, IP में हम 1 ग्राम बोलते हैं, USP में 1 पार्ट बोलते हैं। मीन्स एक पार्ट लिया है सॉल्यूट का और अगर वो 1 <1 पार्ट में डिजोल्व हो रहा है तो वेरी सॉल्यूबल। अगर 1 part of solute dissolves in 1 to 10 part, it is freely soluble. 1 part in 10 to 30 part, it is called as soluble. 30 to 100 part, it is sparingly soluble. 100 to 1000 part, it is slightly soluble. here one thing will be remain common, that is solute concentration, 1 gram or 1 part. Only solvent concentration will get changed. Okay, this 7 class you have to keep in mind. Okay, very soluble, freely soluble. ऑलरेडी आप लोगों ने वो ये मोनोग्राफ्स पढ़ते समय पढ़ा है, अभी ये रिवीजन पार्ट जैसा है. ओके, सो in next class, I will take mechanism of solvent-solute interaction. What is ideal solubility parameters? What is solvation and association? Okay. Next class, I think it is there on next Monday. Uh, till that, you revise all those things. Thank you all.